Hi guys, welcome back. For this video, it's gonna be chapter 4, part 2. Let's start with the first one, which is probability distribution for continuous random variables. For the continuous random variables, the chart is gonna be a smooth curve like this, and the area at the middle, or big A, is will equal to probability of x assumes a value between A and B. So let's move to the first type, which is normal distribution. As you can see, this is a mound-shaped curve, so we can use only empirical rule. And also, when it's a mound-shaped curve, the mean will equal to median and mode. For a normal distribution, this can be used to approximate discrete probability distribution, for example the binomial, and it's used to describe many random processes or continuous phenomena. The effect of different means and standard deviation is here. For example, these two graphs, the difference of these two graphs is first, the mean, because it's placed on a different place. The standard deviation is different because this one is wider. It means that the standard deviation is higher. The wider of the graph, the bigger of standard deviation. The thinner of the graph is the smaller of the standard deviation. The last one is the fx, or the probability density function. As you can see over here, the fx. The fx determines the height of the chart. This will equal to 1 divided by standard deviation times square root of 2 pi and then times e powered by negative 1 over 2 times the given value minus mean divided by standard deviation square. Pi is equal to 3.14 and e will equal to 2.71828. Let's move on. The standard normal distribution is kind of similar to the normal distribution, but the mean and the standard deviation is different. The mean can be only 0 and the standard deviation can be only 1. And here, because on the first one it used to be x and here is z. How to convert from here to here is to use this formula. Z is equal to the given value, which is x minus mean divided by the standard deviation. And after we get z, so we can find the probability of this graph or the area of A. As we learned from last video, the continuous random variable can write like this. because it can be a range, it's uncountable, and it can be infinite. So in the example, I assumes that the range of the value is 8 and 12. The mean is 10, the standard deviation is 1.5. So from z equal to x minus mean divided by the standard deviation, this will equal to 8 minus 10 divided by 1.5 and 12 minus 10 divided by 1.5. This part will equal to negative 1.33 and this one will equal to 1.33. So after we get the z-score, now we can find the area of A. So to find it, you're gonna use the standard normal table Z or the Z table. To find it, Z here, the Z we get is negative 1.33 and 1.33. So we're gonna find 1.33 is here, 1.3 and 3 is here. These two numbers will equal to 1.33 because here is 1.3 and 3. Here is gonna be first two digit and here is gonna be the last digit. So when we get 0.4082, as you can see, the chart is start from 0 to Z. So the number we get is gonna be divided to the half, and this one is gonna be mean, and here is 1.33 and here is negative 1.33. So after we get the 1.33 is equal to 0.4082, here will equal to 0.4082 also, because it's the same number but it's just negative. So after that, we combine it together, we submit to 0.8164. This will be the probability of the x is within the range of 8 and 12. If you want to find the tails over here, if you want to find two sides of it, you can use 1 minus this number and you will get a tail. But if you want only one side, you have to use 0.5 because it's divided by mu and mu is equal to 0. So it's gonna be 0.5 and 0.5 over here. So if you want to find one tail over here, you have to use 0.5 minus 0.4082, which is equal to 0.0918. The last part for today is other continuous distribution. We have two other continuous distributions. First is uniform distribution. We will use it when the continuous random variable have equal probability. So it's gonna show as the rectangle form of the graph. The height of the graph will equal to 1 divided by d minus c. This will equal to the height of the graph, and the mean will equal to c. C plus d divided by 2. C plus d divided by 2. C plus d to get the middle number, and then the standard deviation will equal to d minus c divided by square root of 12. And the probability of this area will equal to b minus a divided by d minus c, when c is less or equal than a and a is less than b and b is less than d. In order this graph, c is less than or equal to a and a is less than b and b is less than d. The last part is the probability distribution for an exponential random variable, or the exponential distribution. The exponential distribution is going to be the graph like this. It's going to be exponential curve. The fx, or the probability density function, will equal to 1 over theta times e powered by x divided by theta again. The mean will equal to theta, and the standard deviation will equal to theta also. I will assume that here is a, so the probability of this area will equal to e powered by a divided by theta. This will equal to p of x more than or equal to a, which is this area. So that's it for this chapter. I will see you in next video.